So we'll come back one more time. So now actually when we perform the when we solve the ordinary differential equations, not always but sometimes we don't get the we don't get the denominator in a suitable form so that we can apply the Laplace table directly to bring the frequency domain or Laplace domain function to time domain function. So to bring the whole thing in a simplified form so that we can apply the Laplace table directly, basically we do the partial fraction expansion. So by doing the partial fraction expansion, we bring the whole thing in a simpler form, and after that we can apply the Laplace table directly. So now for this example, like we have at the denominator we have s plus 2, and at the numerator we have s plus 1, and s square plus 2s plus 2. So for this one, actually we do not have any way to apply the Laplace table for calculating the inverse Laplace form of this expression. So what we will do, we'll do the partial fraction expansion. So when we do the partial fraction expansion, normally three types of things happen. One is the real root. So that means the root is a real number. Like in this case, basically s equal 0 and s equal -1. So these are the real root. And now the complex root for this case is actually s square plus 2s plus 2. Okay. So now my question is how you will understand or how you will feel it's a complex root or not. Like if I write s square plus 2s plus 1, so this is not complex root, this is real root, but whereas this one is complex root, right? Whereas this one is complex root. So once a second order uh, polynomial is given, so how you will understand that it's a real root or it's a complex root, right? Real root or complex root. So the formula is basically how we solve the second order equation. Like if we have as square plus bs plus c equal 0, then s equal minus b plus minus a square root of b square minus 4ac over 2a. And now you tell me when you will get the real root and when you will get the complex root. So you will get the complex root only when the on this expression b square minus 4ac will be greater than b square, that is negative number, -1. So like for this one, b square minus 4ac, once this number will be less than 0, then it will give you the complex root. Okay, complex root. And now, like now if you have real root, you will directly write, like, okay, let me write the whole thing here first, like s plus 1 over s into s plus 3 into s plus 2 whole square, and then s square plus 2s plus 2. So what we have on this expression, we have real root here, we have real root here, we have real root with multiplicity of 2. So s plus 2 whole square. So basically n equal to, or I would say multiplicity is 2, and then s square plus 2s plus 2, this is basically the complex root. So how do I know the complex root? Because the b square minus 4ac is 2 square minus 2, 4 into 1 into 2, so which is basically minus 6, right? So that's why it's a complex root. So if you have a real root, if you have real root, Then okay, let me rewrite the whole thing. So s plus 1 over s into s plus 3 s plus 2 whole square into s square plus 2s plus 2. So we can write this one is equal a over s plus b over s plus 3 plus c over s plus 2 plus d over s plus 2 whole square plus e over s square plus 2s plus 2 plus f over s square plus 2s 2s plus 2 and multiply by s plus 1. Okay, s plus 1. So now there are many questions here. I know there are many questions in your mind, so let me answer one by one. Okay, even the questions, actually I have couple of questions here in my mind for answering. So like first one, if you have real root, you will write in this form. If you have real root with multiplicity 1, you will directly write one time. If you have real root with multiplicity 2, so it will come two times. So the first time it will come c over s plus 2, and second time it will come as a d over s plus 2 whole square. If it has multiplicity of 3 or power of 3, then third one it will come like e over s plus 3 whole cube, right? And now for the second order, I mean that's not second order, I'm sorry, for the complex root it will come two times. So one time is e over, that is 1 over s square plus 2s plus 2, and another time it will come s plus 1 over s square plus 2s plus 2. So why s plus 1? Actually look here, s square plus 2s plus 1 plus 1. So s plus 1 whole square plus 1 square. So I'm bringing the whole thing in this form so that I can apply the Laplace table. Okay, so let me show you the Laplace table, corresponding Laplace transformation. So look here. So one is omega over s plus a whole square alpha whole square plus omega square, which inverse Laplace transform is e to the power minus alpha t sine omega t. And another one is s plus alpha over s plus alpha whole square plus omega square, which the inverse Laplace transform is e to the power minus alpha t cos omega t.